This is a German math competition problem. And I'll be honest with you, it might take away a lot of your brain cells. We begin with a quarter circle. The radius of this circle is 4. Along the straight edge of that quarter circle, we draw another semicircle inside. This new semicircle uses the straight side as its diameter. It touches the larger semicircle at exactly 1 point. The question is, what is the area of the red shaded region? Can you figure it out? And if you think of a different method, share it in the comments. Alright, let's work through the areas step by step. The area of the quarter circle is 1/4 times pi times 4 squared. That simplifies to 4 pi. Now look at the semicircle at the bottom. Its radius is 2. The area is 1/2 times pi times 2 squared, which equals 2 pi. For the other semicircle, the one drawn inside, we don't yet know its radius. So let's call that radius r. Its area will be 1/2 times pi times r squared. So how do we get the shaded region? We take the quarter circle's area and subtract the areas of both semicircles. That gives us 4 pi minus 2 pi minus 1/2 pi r squared. If we factor out pi, it becomes pi times the quantity 4 minus 2 minus 1/2 r squared. So the real problem is this: how do we find r? Here's a key fact about circles. When two circles are tangent, the line connecting their centers always goes through the tangent point. That's because the radius to the tangent point is perpendicular to the tangent line in both circles. So if you connect the centers, the tangent point must lie on that same line. Now, let's look at the right triangle that forms between the centers. One leg of the triangle is the radius of the small semicircle, which is 2. The other leg is the distance 4 minus r. And the hypotenuse is the sum of the two radii, which is 2 plus r. By the Pythagorean theorem, we know that 2 squared plus the square of 4 minus r equals the square of 2 plus r. Now we solve that equation. When we expand and simplify, we find that r equals 4/3. That means r squared equals 16/9. Finally, substitute this value back into our shaded area formula. Simplify carefully. That becomes 10/9 pi, so, the area of the red shaded region is 10/9 pi.